Hello and welcome. I'm Hullhound and today we'll be making a Frogger clone. For those of you that don't know, Frogger is a game from the 1980s where you take a little frog and you move it towards the other side of the map to collect other frogs. You do that by avoiding cars and vehicles and navigating across the water. We'll be doing it slightly differently. So we'll be using a pack made by Kenny, using a tiny battle pack that is quite nice and neat and does everything that we need it to. So, the first thing we need to do is open Godot and create our new project. So we can do that by selecting new, and then we have the create new project dialog. So in this case, I'm going to call the project with today's date and Frogger. I've already selected the path that I want to add my project to. In this case, you can select browse to use the file system. I've just written in the path as is. I can then press create folder, which will create a new folder underneath that path, and then I can press create and edit. Worth noting, we have the renderer option here, so I like to use compatibility because I like to put things on the web, which is best, but we also have things for mobile and forward plus, which is more for your desktops. I'm just going to stick with compatibility for the moment. Feel free to use whichever one you want. It doesn't impact what we're doing in this course. Version control metadata is useful depending on how you'll be version controlling your project. I'd recommend just keeping it at the default of Git. Once we've done that, we can press create and edit. Once that's loaded, we get a brand new project. So for those of you that aren't familiar, I'll just briefly go through what we can see on screen and a little bit about the interface. Starting from the top, we have our standard menu items. I won't go into too much detail on those at the moment. Here we have our scene view. So at the moment, we have this as blank and it's suggesting that we enter a scene. We'll touch on that later on, so I won't go into too much detail of that, but just know that this is the area where all of our objects live. Below that we have the file system, and this is a representation of your own file system and the files that are available within the project. In the center, we have the main viewport. So we have the option of selecting 2D, 3D, scripts, and asset library. For the purpose of this course, we'll be focusing purely on 2D and script. So 2D allows you to manipulate a game objects within a 2D world. So that also includes things like your user interface. And then scripts is where you can actually code various pieces of code. On the right hand side, we have the inspector, which allows us to set properties on each of our objects and nodes that we have. There's also some more tabs up here, but we'll touch on those as they become relevant. Our first step before we get started in earnest is to load in the images and files from Kenny into our project folder. So all I've done is unzip that and added it into the relevant folder on my file system. Once you've done that and then return to Godot, it will automatically update down here in the file system window. So the first thing we want to do is set up a level. In our case, it's a 2D level. So on the left-hand side, we can select our root node. So typically we have scenes and nodes. Both of them represent some level of functionality that is part of our game. In this case, I'll select 2D node. Since I know it's a level, I will rename it to be level. On the right-hand side, you can see the properties that this node has. As it's the node 2D, it has all the properties that allows an object to be a 2D thing, as well as everything that is more generic than it. So in this case, we can see node 2D is a child of canvas item, which is a child of node. Node 2D has the following properties, specifically position, rotation, scale, and skew, which are the properties that allow it to do 2D related things. For us, we want to add a map. So to do that, we use another node. So scenes can have nodes, as part of them as children, and indeed nodes can have much the same. It's a hierarchical structure. From a practical point of view, a scene and a node aren't really different, other than you can open a scene to see the nodes that are contained within it. So I'll add a child node to our level, and in this case I'll select tile map. So a tile map is an object that allows us to build up a 2D scene from a set of smaller images, for example, which is what we want to do. So what I'll need to do is select tile set on the right and select new tile set. That will then create a tile set resource for me, which is effectively a file that contains some information, in this case about tile sets. Once I've selected that on the right, I can, at the bottom, select tile set, which allows me to select tile related information. In this case, I want to press plus to add an atlas. So fairly helpfully, when Kenny created his pack that we're using, he created a tile map folder that contained all of the objects that we need in a atlas, or texture atlas as they're called, which means that we can then use these directly. There isn't any real difference between tile map and tile map packed. I'm going to select tile map packed. Here it's suggesting the recommendation that we should create tiles in the atlas automatically. No reason why not to. So I'll select yes. Here we can see that our tile size is 16, which actually matches what is available for our tile set. So it's quite neatly created each of these in the format that we would like. So as you can see here, we have access to a number of different images. For the purposes of what we're making, aka Frogger, we have a set amount of rows and columns, or a certain size of map. So to do that, we want a win row, which is 15 columns. Sorry, we select paint. In this case, box will work, and I'll select water. So I need 15 columns of water, and that will become our win row later. I then need a further 5 rows of water, where our logs and frogs will come in. I then need a safe zone, which is grass. And then I need some roads. I'm sure you can just kind of see me doing it, but all I'm doing is selecting the tile I want to draw effectively. And in this case, I'm using the rectangle tool, which lets me select a box to just duplicate that tile. And to finish off, we'll have an additional safe zone, which we'll start. And then for the purposes of the game, we'll have another row beneath it where our lives and collected score, or flags, will be. At the same time, just because we may as well pretty up a little bit, I'm going to select some of these and add in just a few nice little additions to make it look a bit nicer. So that's our map. You can zoom in and see it in a bit more detail. If I select off the tile map, it will stay, but the grid will disappear. At this point, we can admire our handiwork. If we press F5, it will ask us to select the main scene. This main scene effectively is the default scene for the purposes of this, and it's suggesting that we do select current, which we may as well do. We haven't saved it, so it gives the option to save the file, so I'll do that. I'll just save it to the root folder, and we can now see that our map has shown up. Okay, so at this point we can see that our game screen is taking up only a very small portion of our game screen. So let's fix this. Let's close that window. Going to project and project settings. This is where all the settings about the game is stored and can be impacted. So in this case, we're worried about the display. So let's go to display window. Here we can see the viewport width, height, etc. that we're interested in. So each of our tiles is 16 by 16. So for a width of 16 times 15, and you can just write that in, press enter, it will select it as 240. Similarly, our height is 14 times 16. So we can just do that, and that gives us what we need. So if we were to close that, and then press F5, we now have exactly what we needed, albeit quite small. So let's make it bigger. So let's double its size. Go to Project, Project Settings. If we go into here and select ×2, then you might think that's everything we need. But actually, what that does is means that we have only a quarter of our screen being used. So what we instead need to do is scale up the tiles that are here also to be twice the size. And we can quite happily do that down here. So here we have stretch mode. So what we can do is select canvas items and then a scale of 2. And if we select integer, it just plays a bit nicer with pixel art. And then we try again. What that does is gives us a larger playing screen for our game. What is a game without a main character or a player? So, as I said before, a scene is made up of a collection of nodes. So let's add a node. In this case, we want a player. So in this case, I'm just going to add a standard node 2D, and we'll build up the functionality that we need as we go. So I'll create that, and I'll rename it to be player. So a player is a specific thing, and it's going to get much more complicated than what we have here. So what I like to do is right-click, and save branch as scene. If I then save that into the same folder, I now have turned that node into a scene, which means I can drill down into it and access its internals. So in this case, it looks exactly the same as it did previously. But here we can flesh it out a little bit. So what I want to do is add a visual to the character. So in this case, I can add a child node. The default node that deals with displaying a simple image is a sprite 2D. Let's add that in. Here we can go to texture, and we can select what image we want to use. In this case, we can select load, and we can then go into the asset folder. In this case, we only want one image, so we can just go into tiles, and we can find an image that we want to use as our character. I think I'll go for a red character, so I'll go for this one. If I zoom in, then what you can see here is our player character. So it is worth noting that by default, the sprite starts in the center of your character, for example. What I would like to do is have it not centered so that it fits more into our 16 by 16 tiles. So I'm just going to unselect centered. I press save and go back to level over here. We can see that our character is in the world. Quite neat. I want our character to start off down here, however. So I'm going to take advantage of some of the properties of the player, in this case its position, to move it to this location. So as I know that we're wanting to go 13 tiles down, I can select here. It is worth noting that in Godot, your origin is here. So Y goes down as you go further down the screen. So in this case, what I want to do is do 16 times 14. Should do it. Of course, that's too much. So in that case, I can do 2 times 16, which gets me to the correct row. From there, I want to move a little bit into the middle, so I'll just do 7 times 16 to move me there. So now everything's in place. You can see it's been reflected here, which is nice and neat. Now that we can see our player character, let's make him move. So what I'm going to do is I'm going to go into script, I'm going to select File, New Script, and I'm going to call this Direction Input Mover 2D. Because what I'm wanting to do here is I'm wanting to create a script that listens effectively for the arrow keys and then moves the character depending on that within a 2D world, hence the 2D on the end. If I press create, you'll see that it's been added into our file system at the bottom, and we're presented with the following screen. I'll just move the console out of the way. By default, we have a fairly standard structure. So we have extends node, which indicates it extends a root node. In this case, node, which is fairly straightforward, which means it has no other functionality by standard. We get the ready function, which is a function that runs when our object is added to the scene or first set up, and then the process function, which runs every frame of the game. And indeed, we have helpful text just to explain that to us. It's worth noting that by default, we have this in GDScript. So GDScript is the programming language that's built into Godot. I quite like using GDScript as because it's added into Godot by default, you get a lot of things that are fairly well integrated into the engine. But anyway, let's move on to actually making this node do what we want it to do. For the purposes of this, we can remove the ready in process. We won't need them. What we want to do is listen for unhandled input. So in this case, we're looking specifically for key presses. But how we do that is we write a func to suggest it's a function. I'm wanting to override a function that already exists, and specifically a private one. So underscore is the convention for a private function. So that means that it's not expected to be used by anything outside of the node itself, but we can get it from our parent. So in this case, I'm after the unhandled key input. If I select this, I get the signature of the method, and I have an input event, which I can get information about which keys have been pressed. What I want to do is listen for only some inputs. So specifically, I'm looking for up, down, left, and right. And I want this to be a condition. So how we do the simplest form of condition in Godot is the if statement. So if I write if, and then I look at this event, so event dot is action released. That's again when the button is let go of, rather than when it's pressed initially. That's a preference. You could equally make it is action pressed. But we'll go for is action released. I then have a selection of actions here. And there's a variety of them here. Of note, up, down, left, and right are not here. So we need to add them. We can do that by going to Project, Project Settings, and then going to the Input map. Here we have our custom actions. You can see there aren't any. Changes, I can enter in up, down, left, and right. That doesn't do anything by itself. I need to assign these to keys. So I press plus, I can then select the up arrow, and it appears automatically selected for me. I can press OK. I can then do much the same for the rest. This does, of course, mean that you could select and change these to any keys that you desire. It does not actually just need to be the arrow keys. But I'm going to keep it as that. If I now return to our script, you can see the up and the other ones have been added. There's a syntax thing. A if statement ends in a colon, and any code that needs to be run as part of the if needs to be indented. It's important to note that in GDScript, indentation does matter. So please keep an eye on that to avoid any frustrating problems. So once we have our up, we need to know what we're going to do. So what I like to do is have each node take in all of the inputs that it needs, because it makes things easier. rather than having things be assumed. So what we need to do is, in much the same way as we set the position on the player, we need to say to this node, what are we going to affect? In this case, it will be the player. So how we do that is we use the @export keyword. And then here we can do var to say variable, so we're exporting a variable, which then makes it available in the inspector. So in this case, I'm going to call it target, and I'm going to say that it's a node 2D. This means that I can assume that anything that gets added into the target field has all the properties of a node 2D. For the purpose of this, I'm most concerned about position. I can now say target.position. Because we're moving up, we're reducing the y value. So in programming, we typically do variable equals, and then its new value. So in this case, I can do target.position equals its current position minus, and then because we know our tile size is 16, we can write in 16. There's two little improvements we can make here. So one is we can remove the redundant aspect of saying we're setting it to itself with a change by using minus equals, which just means that it's this value minus, which is itself, minus whatever's on the right hand side. In addition, it's normally a good idea to not put in any form of magic numbers. In this case, 16 is a number because somebody else looking at this code might not know why it's there. So instead, we can add a new export variable. In this case, we'll call it movement amount. And we can just set that to 16. That's by default, so it can be changed by somebody else, but by default it will be 16. So I put this in, but it doesn't do anything. So what I will do is I'll move to the player scene. And what I want to be able to do is add this node in much the same way that we did the sprite 2D. In order to do that, I need to give it a name. So we write class name, class underscore name, and I'm just going to call it the same name as the file. So direction input mover 2D, and then save the file. Now, if I select player and press plus to add a child node, I can see that my node is here, and I can press create. And we can see on the right hand side that the variables that we've selected for export are available to be assigned, with 16 being set as a default value. I can press assign and then player, and what I would now expect that if we press F5 to open up our scene, I should be able to press plus and move our character up. I cannot, however, move it in any other direction. So let's add it the ability to move it down. So with an if statement, we have its companion, which is else if, or in Godot, it's elif, which just means else if. So if the first condition does not match, look at the second condition, and then you can chain these as many as you want. So in this case, I'm going to do is action released down. And I'm going to do the opposite. So target.position dot y plus equals to mean the same number plus a change. And now if I enter the game, I can move up and I can move down. So if you'd like a little challenge, pause the video now and try to add in left and right. Okay, hopefully you're back. So let's keep things nice and easy. We can just copy and paste this, add it underneath, and then change this to elif rather than if. Change this to left. Change that to right. Change that to X as we're moving on the X axis for left and right. And then if we press F5, we now have the ability to move in all 4 directions. So that's it for this video. We're going to stop there and we'll continue in part 2. Remember to subscribe in order to be notified of when that comes out, and see you next time.